Lab 1 Charged Tape. The purpose of today's video is to prepare our two charged tapes and observe their interaction with negatively charged objects. Through this observation and the observation of the two tapes, we can determine the tape's excess or deficient charge and the number of electrons transferred. The main lab result we will see by the end of the video is 1. The tapes are positively charged and we will see that they repel each other, and 2. The tape charge was estimated to be 1.497 times 10 to the negative 8 coulombs. And finally 3. The tape was deficient of 9.35 times 10 to the 10 electrons. The main physics ideas that are present in this experiment are Newton's second law, force equals mass times acceleration. We also need the acceleration of gravity, 9.81 meters per second squared. Additionally, we will need to use Coulomb's law, 1 over 4 pi epsilon naught times q1 q2 over r squared, where the k constant is equal to 9 times 10 to the 9 Newton meters squared over Coulomb squared. This will help us find the electric force of charged particles. In this experiment, two tapes, which we will call tape A and tape B, were ripped off of a base tape that was stuck on my desk, which either made it gain or lose electrons. I then brought objects near tape A to test if it was electrically charged. Next, tape A was placed beneath tape B, and the displacement of the repelled tape was measured. The initial condition for this experiment was the tape length measured at 0.214 meters, tape width at 0.02 meters, mass at 2.14 times 10 to the negative 4 kilograms, and tape distance when repelled was 0.031 meters. The system was tape B while the surroundings were tape A and everything else including the earth. During the experiment, I observed that the tape was attracted to my hand, a negatively charged pen, and a negatively charged plastic ruler. Through these observations, we can conclude the tape is positively charged, meaning there's a loss of electrons. I then proceeded to make some calculations with the data I gathered. The area of an atom was estimated to be an angstrom squared, or in this case, 1 times 10 to the negative 20 meters squared. The number of atoms in the tape was found by dividing the tape area by atom area, which was 4.28 times 10 to the 17. The force of gravity was simply mass times acceleration, which was negative 2.097 times 10 to the negative 3 newtons. To find Q, the charge, I solved for it in the Coulomb's equation, and I got 1.496 times 10 to the negative 8 coulombs. The number of electrons lost was found by dividing Q by 1.6 times 10 to the negative 19. This gave me an answer of 9.35 times 10 to the 10. In the code, I wrote all the constants and initial values I mentioned in the previous slides, like tape length, width, atom length, and gravity acceleration. Using these numbers, I coded some calculations to find and print some of the important values, like electric force and charge. Finally, I modeled a blue and red sphere along with two arrows to help visualize what is going on in the microscopic level. Some of the similarities I found between the real experiment and computational experiment include the force of gravity and electric force are equal in magnitude but opposite in direction. This is supported by Newton's third law. The calculations for force and charge were computed the same way, and one major difference was that the tape is modeled as a point particle in the code, but in real life this isn't necessarily true. And the second difference is that the magnitude of force on the code is much smaller than what you are seeing. I simply scaled the arrow by 10 to help as a visual aid. What if electrons had a positive charge and protons had a negative charge? The loss of electrons would result in a negatively charged tape. Other than that, there isn't anything else that would change. Tape A and other objects would still attract, and tape A and tape B would still repel. We would see the same interactions because opposite charges attract and like charges repel. Why is it important to handle the charged tapes as little as possible? Well, we want to reduce the transfer of electrons between the tape and hand. We want to minimize contact to improve the lab results. Likewise, we should maintain the tape with care so that it maintains its charge. Otherwise, a smaller charge would mean a smaller force. In conclusion, we can determine if an object is negatively or positively charged by observing its interaction with tape. We use Coulomb's law to estimate the charge in an object, and by determining charge, we can calculate the number of electrons lost or gained. Some potential sources of error in this experiment include the neglection of air resistance. The room where the experiment took place was humid, and there might have been excessive contact with my hand, which might have skewed the data.